The soil reaction is measured by pH of a suspension of soil in water. It is conveniently expressed by a logarithmic scale. It was suggested by Sorensen in 1909. pH means puissance de hydrogen. It's a French word meaning power of hydrogen. By definition, pH is the negative logarithm of the hydrogen ion activity of the soil. The concept of pH may be explained with reference to pure water which is amphoteric, and in which hydrogen and hydroxyl ions are in equilibrium with undissociated water molecules. Water, as you know, can act as both acid and base, the amphoteric nature. And here, the hydrogen and hydroxyl ions will be in equilibrium with undissociated water molecules in pure water. Now, it was experimentally determined that the product of the concentration of the hydrogen ions and the hydroxyl ions in pure water is 10 raised to minus 14 grams per liter at a temperature of 25 degrees centigrade. At a temperature of 25 degrees centigrade, the concentration of the hydrogen ions and the hydroxyl ions in pure water was determined to be 10 raised to minus 14 grams per liter. Now, in neutral solution and in pure water, the concentration of hydrogen ions and the concentration of hydroxyl ions are equal. That is, the concentration of hydrogen ions and the concentration of hydroxyl ions will be half of 10 raised to minus 14, which again is equal to 10 raised to minus 7 gram ions per liter. pH is the negative logarithm of hydrogen ion concentration. Therefore, pure and neutral water will have pH is equal to minus log 10 to the power of minus 7, which again is equal to minus of minus 7. So pH is equal to plus 7. That is how pure neutral water has a pH of plus 7. Now, the acid solution will have a hydrogen ion activity greater than that of pure water. That will be greater than 10 raised to minus 7. And alkali solutions will have a hydrogen ion activity less than that of pure water. So it should be less than 10 raised to minus 7. Hence, the hydrogen ion activity of a solution can vary from 10 raised to 0, as in the case of a normal solution of strong acid, to 10 raised to minus 14, as in the case of a strongly alkaline solution. But the product of the concentration of both the hydrogen and hydroxyl ions will always be 10 raised to minus 14. So the acidic range will be from 7 to 0, and the alkaline range will be from 7 to 14. Now, the pH is measured using a pH meter. Now, if you look at the components of a pH meter, it consists of two major components. The first one is a sensor, which produces an electrical signal which is proportional to the parameter to be measured. And the second one is the instrument per se, which measures and processes the signal and finally displays it on a meter. This can be in two modes, either in the digital mode or in the analog mode. Now let us see how a signal is produced in the pH meter. So in the pH meter, the electrical voltage signal is produced by a pair of electrons. One of these electrodes is a hydrogen ion sensitive electrode which produces a voltage signal which is in accordance with the hydrogen ion concentration of the test solution. And this electrode is called the hydrogen ion sensitive electrode. The second electrode is called the reference electrode. The reference electrode also develops potential, but it remains constant, unlike the hydrogen ion sensitive electrode. And the potential does not change with the changing hydrogen ion concentration of the solution. Now let us see the principle of working of the pH meter. So earlier it was said that the pH meter works on the electrical voltage signal that is developed. So here a difference of 1 unit of pH in the acidic side produces a voltage change of approximately positive 60 millivolt. 1 unit pH in the acidic side produces a voltage change of approximately plus 60 millivolt. On the other hand, if the pH is alkaline, say if the pH is 8, then the voltage difference produced will be minus 60 millivolt. A negative voltage means alkaline or pH more than 7, while a positive voltage means acidic or pH less than 7. So what will be the range of a pH meter in terms of millivolts? A pH meter of the range from 14 to 0 will have a millivolt range of minus 420 millivolt to plus 420 millivolt, with 0 at the center, representing pH of 7. And if the meter is provided with a switch to measure the negative and positive voltages, then it can have two ranges of pH. 7 to 0 measured as positive 0 to 420 millivolts, and 7 to 14 measured in the negative 0 to 420 millivolts. The pH meter has two input terminals, one for the hydrogen ion electrode and the second for the reference electrode. Now, more recently, the two electrodes have been combined into one, and it is called the combined pH electrode. The voltage by the electronic circuits is measured, and finally it is displayed on a digital or needle type meter. There are several pH responsive electrodes that can be used, which include hydrogen gas electrode, quinhydron electrode, antimony electrode, and glass electrode. But the most commonly used electrode is the glass electrode. The glass electrode is actually a membrane electrode, which is comprised of a thin walled bulb, which is made of pH responsive glass. This bulb is sealed to an ordinary glass tube. Both the surfaces, the inner as well as the outer surface of this glass membrane, is pH responsive. And in the inside of the bulb is filled with an electrolyte of high buffer capacity. So an electrolyte of high buffer capacity fills the inside of the glass electrode bulb. And in the electrolyte dips an internal reference electrode. The reference electrode is dipped in the electrolyte which is held within the glass bulb electrode. And the reference electrode is generally a calomel electrode or a silver chloride electrode. Now let us have a look at the procedure for the measurement of pH. So the soil water ratio is 1:2.5 mass by volume. So you have to take a 50 ml glass beaker with a glass rod, transfer 10 gram of weighed soil into the beaker, add 25 ml of distilled water into it, and using the glass rod, you have to stir the suspension at regular intervals for 30 minutes. So intermittent stirring now and then for about 30 minutes have to be carried out. Now at the end of 30 minutes, the suspension has to be again stirred well, and then you have to immerse the electrode of the pH meter into the glass beaker and take the measurement. Calibration of the pH meter is important. We have to calibrate the pH meter before the actual measurement. Standard buffer pH solutions can be made use of for this. Standard buffer solutions of pH 4, 7 and 9.2 are commercially available. It is better to first set the buffer 7 and read its value first. If the pH meter shows slightly less or more than 7, then turn the knob to bring the reading to 7. Next step is to calibrate with either 4 or 9.2 buffer. Again, if there is difference in reading, set it right with the help of the calibrating knob or the slope knob. After removal of each buffer, the electrodes are carefully flushed off with water. Now the calibration is over and the pH meter is ready for measurement of the soil sample.